So this is the correct partial fractions for it. You have an irreducible quadratic factor on the denominator. And so the correct form would be a of x plus dx plus c of x squared plus 25. Clear the fractions with your denominator. You will be left with 3x squared plus x plus 50. On the left, and a times x squared plus 25 plus bx plus c times x on the right hand side. You put x equal to 0, you will find that a is 2. Then you will put x equal to 1 on both sides. If you put x equal to 1 on the left, it will be 54, 26a plus b plus c. And then if you put x equal to negative 1, you will be left with 52, 26a plus negative b plus c times negative 1. And you solve those two equations. You should get c is 1, b is 1. That is to say, this will be your partial fractions. And you can go home and integrate that. Okay, the next topic we want to start is, well, the next real topic is improper integrals. But before we do that, we need to remind ourselves how to do a little bit of limits. Yes. Now, I hope you all know how to do some basic limits, because that's really what you did in calculus. Yeah. Now, you know, if you have something like this, so basically we're going to do L'Hopital's rule for limits.
Yeah, this section.
Now, if you have something like this, what is that limit?
What's undetermined?
Now, you would have learned that in pre-calculus. If not in pre-calculus, you should, sorry, in calculus 1. If not in calculus 1, you should have at least learned it in pre-calculus. You say there's a rational function and the numerator has degree 2 and the denominator has degree 2, so that when x is very big, you don't need to worry about this. You don't need to worry about that. And when x is very big, you have 5/3. 5/3. You can check it. You can put in your calculator a large value of x. Say x is 1,000,000 and see what you get. You should get about 1.66666. And how about something like this? Now, the problem with this limit here is the question becomes, what is infinity divided by infinity? Huh? Thank you for jumping into that trap. Do not tread where, do not walk where angels fear to tread. Now, if you had a good calculus one professor, he or she would have told you, you have infinity divided by infinity. Today it may be 3, tomorrow it may be -5, the day after it may be 0, and the day after it may be infinity. It changes. In other words, you have to be very careful. Now, Mr. Boji, when x is very big, this is infinity. Are you with me?
Yes.
And when x is very big, this is infinity. So infinity divided by infinity today is what? 5/3. Oh. Tomorrow it will be 3/4. It changes. Be very careful. What is infinity divided by infinity?
That is infinity.
Infinity! Are you with me? As x goes to infinity, this goes to infinity. As x goes to infinity, this goes to infinity. And what is infinity divided by infinity here?
0.
0. What's going on? You say, be careful. Huh? Yes. Be careful. Now, if you had a good if you had a good calculus professor, he or she would have told you 0 divided by 0 is what? Today it's 5. Tomorrow it's 2/3. The day after it's 0. The day after it's infinity. You have no idea. In fact, those are the kinds of limits you should have learned in Calculus 1, the worst kind. 0 divided by 0. This one here! As h goes to 0, this goes to?
0.
As h goes to 0, this goes to? 9 minus 9 is?
0.
0 divided by 0 today is what? 6. Ah.
That's just.
Yes. It's the derivative of x squared evaluated at 3. What's the derivative of x squared evaluated at 3?
6.
2 times x, 2 times 3 is 6. 0 divided by 0 today is what? Tomorrow.
10.
10. Whoa. What is this as h goes to 0? What is this as h goes to 0? 0. So you have to be very careful with limits. Huh? Now, if you don't believe me, Mr. Boji, you can ask Ms. Yasmina how she did this in her Calculus 1 class. Ms. Yasmina, if you had no idea how to do this, how would you do it on your calculator? You would look at 5 plus x squared minus 5 squared divided by x and let x be very small to make a table, huh? Did you do such a thing in Calculus 1? Good. Who else did it in Calculus 1? Good. Did you do it, Mr. Boji? You have to do this. You'll say x, 5 plus x squared minus 5 squared divided by x, and you will let x go to 0. In other words, but you're not allowed to put in 0 here. You know that, huh? You cannot put 0 here. You know that, right? Yeah. So you will let x go to 0. You'll start at 1 and then go closer to 0. You will try what?
0.1.
0.5. And you will get even closer to 0. You will try what? 0.1. You get even closer to 0. You will try what?
Zero.
0.001. I will show you that this number is what? 10. Oh, your calculator is burnt. It's burnt? Who burnt it? Mr. Jasmina is going to say, oh, we did that so many times, too many times, Dr. J, you don't have to review it. Right, Ms. Yasmina? What function am I looking at? 5 plus x squared minus 5 squared divided by x. Put in parentheses. Do you see that function, Mr. Boji? 5 plus x squared minus 25 divided by x, and I'm going to let x be very, very small. How small? Well, I want to look at the function. Zero 0.5. $10.5. But that was not close to 0. I'll get even closer. 10.1. That was not close to 0. I'll get even closer.